Every month, around the third or fourth, there's a moment at high growth companies where the finance lead and the engineering lead open the same invoice at the same time, and it's never the number they expected. Nobody signed off on this bill. Nobody clicked approve on a big jump in spend. It just happened. Somewhere between a load spike on a Tuesday and a test cluster nobody remembered to shut down, the number moved on its own. And now someone has to explain it in a leadership meeting. Welcome back to Tech Stack Breakdown, where we pull back the curtain on the software architectures running the modern business world. Today we're getting into the FinOps crisis, why cloud bills spiral in the first place, why it's so easy to miss in the moment, and which tools engineering teams are actually using to get control back. And to be clear up front, this isn't really about bad engineers or reckless spending. See, nobody on an engineering team is rewarded for shaving a few $100s off a server bill. They're rewarded for shipping features and keeping things from breaking. So the bill drifts upward by default, quietly, until someone from the finance side finally asks the question out loud. That's the gap we're looking at today. Here's the pitch cloud vendors give you. Pay for what you use. Traffic goes up, you scale up. Traffic goes down, you scale back down. And the bill follows. In practice, scaling up works great. Scaling back down barely happens on its own. And there are a few reasons for that. One, engineers over-provision. And honestly, who can blame them? If a service needs 2 GB of RAM to run safely, a lot of teams will spin it up with way more than that, just so nothing breaks under pressure. It works. It also means you're paying for capacity you're not using. 2, orphaned infrastructure. A team spins up a staging database or a test cluster during a sprint, ships the feature and moves on. The storage behind that test environment doesn't get cleaned up. It just sits there quietly billing with nobody watching it anymore. And 3, the tools finance teams grew up on were built for purchase orders, not for an environment where one script can spin up 500 servers in 10 seconds. Traditional accounting just isn't built to see this stuff happening in real time. So a whole category of tooling has grown to close that gap. Let's go through how 4 of them actually approach the problem differently. If you're all in on AWS and nothing else, start with Compute Optimizer. It's already sitting inside your console, and it costs nothing to turn on. It watches your utilization over time, CPU, memory, network, and when it sees a server that's consistently underused, it recommends a smaller instance type, sometimes a different instance family entirely. You get a list of recommendations, you review them, and you decide what to act on. The catch is that it's advisory and not very automatic. Nothing gets resized for you. Someone still has to go through the list and make the change, so it's only as useful as the engineering time you put behind it. It also only sees what's happening inside AWS. If your stack spans multiple providers, or your waste is actually happening at the Kubernetes layer instead of the raw VM layer, this tool is blind to it. But for a small single cloud team though, it's the obvious first move before you spend a single dollar on anything else. Most companies are in running just one cloud. It's AWS for compute, Snowflake for the warehouse, Datadog for monitoring, and each one built separately, in its own format, on its own schedule. Vantage's job is to pull all of that into one place. It connects to your providers through their APIs and rolls everything into a single dashboard, broken down by team or by project. So an engineering lead isn't logging into 4 consoles just to figure out who spent what. Here's the limit though. Vantage is a visibility layer, not an optimization engine. It's very good at showing you where the money is going. It won't tell you why a specific service is expensive at the code level. And it doesn't fix anything on its own. That part's still on your team. If your problem is we don't actually know our own numbers, this closes that gap fast. If your problem is we know the numbers and we need to act on them, pair it with something else on this list. Kubernetes creates its own version of this problem. You've got dozens of services sharing the same pool of servers to save money, which is smart, but it also means your cloud bill can't tell you which team's code is actually driving the cost. It's all a one-line item. Kubecost sits inside the cluster itself and breaks that shared cost down by workload, namespace, or team, using the metrics Kubernetes already tracks, so you can attribute spend to whoever is actually responsible for it. The obvious limitation: if you're not running Kubernetes, none of this applies to you. And even for teams that are, Kubecost only sees inside the cluster. It won't help you with, say, an orphan storage volume sitting outside it, or a snowflake bill piling up next door. It's a specialist tool for a specific and very common blind spot, not a full replacement for something like Vantage. And then there's the question a lot of finance teams eventually ask. It's not just what did we spend, it's what does it cost us to serve one customer? Finout tries to answer that by combining infrastructure spend with your own product usage data. So instead of just seeing a database bill, you can see roughly what it costs per active user or per transaction to run your product. That's a meaningful shift for board level conversations because it turns an IT line item into a business metric people outside engineering actually understand. Two honest caveats here. First, this only works if your usage data is clean and well instrumented. Messy product analytics means messy unit cost numbers, no matter how good the tool is. Second, this is enterprise tier software, priced and built for companies that already have real FinOps maturity. It's overkill if you're still trying to figure out your basic cloud bill. Think of it as a tool you graduate into, not the one you start with. So which one's right for you? It really comes down to where the pain actually lives. If you're a small single cloud shop, there's no reason to look past Compute Optimizer. It's free, it's already in your console, and it's the easiest win on this list. Once you're spread across multiple providers and nobody can agree on the real total spent, Vantage is the one that gets everyone looking at the same numbers. Teams running Kubernetes have a different, more specific problem: a shared server pool with no way to attribute cost by team. And that's Kubecost's whole reason for existing. And once a company is mature enough that the board wants cost tied directly to margin instead of a raw AWS total, that's the point where Finouts start to make sense. Most teams don't end up picking just one. It's common to see Compute Optimizer running for the free wins, Kubecost layered for the Kubernetes piece, and something like Vantage or Finout sitting on top once leadership wants the full roll-up. These tools stack more often than they compete. What none of them do is fix a bad architecture decision. If a service is fundamentally overbuilt, no dashboard rewrites the code for you. What they actually buy you is early warning, catching the problem while it's still a 2-line message in Slack instead of a 6-figure line item someone has to explain in a board meeting 3 months from now. Real stacks, real decisions every week. This is Tech Stack Breakdown. Subscribe.